lecture for this section is on one more type of logical statement, what's called a conditional statement or an implication. Okay? And so these are statements of the form if A, then B. We talked a little bit about if A, then B, else. Those are slightly more complicated conditional statements combined with other things. So we're just going to stick to if A, then B. And what we're going to do is we're going to talk about whether a statement like that is true or not. Because it turns out to be actually kind of an interesting question. So if you look at the statement, if it rains today, we'll watch a movie. Very simple conditional statement. A here is it rains today. B is we'll watch a movie. Okay? So we write this as A, then an arrow, and B. This symbol makes a lot of sense, right? Because we're saying if A, then B. And so B kind of follows from A, and so that's why we use this arrow. So if it rains today, we'll watch a movie. A, and then the arrow B. A implies B is how we usually read this. So if A, then B. Okay? So what I want to think about is, when is this statement true? Because this is a logical statement like anything else. And so one example, so if it rains today and we watch a movie, then the statement is certainly true, right? Because we haven't violated what we said we were going to do. But if it rains today and we don't watch a movie, this statement is false, right? Because if it rains today and we don't watch a movie, we haven't lived up to what we said we were going to do, right? So if you think about like arguing with a little kid and you said, oh, if it rains today, we'll watch a movie, and then you don't watch a movie even though it's raining, that kid's going to come back to you and be like, oh, you said we would watch a movie today. That was a lie, right? So those two situations are kind of the first two in our truth table. So if you think about setting up a truth table for A implies B, if A is true and B is true, right? If it rains today and we watch a movie, then the whole implication was true. We lived up to it. But if it rains today and we don't watch a movie, so if A is true and B is false, then our statement was false. It was a lie. Okay? Where this gets more interesting mathematically is the last two cases. So if A is false and B is true, or if they're both false. Okay? And so mathematically, what we say is that in fact, if A is false and B is true, and this is the one that always kind of gets people, we say that this statement logically is still true. Okay? Same way if they're both false. So let's talk about these in terms of our example. So if A is false and B is true, it didn't rain today and we still watched a movie. Does that contradict what we said? So we said if it rains today, we'll watch a movie. It didn't rain and we still watched a movie. That really doesn't contradict what we said, because we didn't say anything about what we were going to do if it doesn't rain today, right? We said if it rains today, we'll watch a movie. But if it doesn't, we haven't said anything at all about that. And so we haven't contradicted the statement. The statement was not a lie. It didn't get tested because the first part, A, was false. Similarly, if A is false and B is false, if it doesn't rain today and we don't watch a movie, okay. It's still, we haven't tested whether it's true or not, and so the statement is still holds. We didn't contradict ourselves. And so this is the truth table for A implies B. If they're both true, it's true. If A is true and B is false, that's the only situation where A implies B is false. Okay? And so where this can be interesting, where we can kind of look at this, is that a lot of people don't really kind of follow through and actually use this logic correctly. Okay? So let me give you an example of a misleading statement that you hear all the time that uses a conditional. Okay? So I'm going to go ahead and erase this, but we'll use it in a second. So actually, let me go ahead and kind of put it up here just so that we've got it. A, B, A implies B, just so we can refer back to it. Right, so only false if true and then false. True, true. So we're going to refer back to that. So the statement I want to talk about is, you'll hear this a lot from kind of like used car dealerships or kind of those like TVs on local, those commercials on local TV. You'll hear people say, if you didn't buy it from us, you paid too much. Right? Always with an exclamation point, right? You wouldn't say this and say, oh, if you didn't buy it from us, you paid too much. You would say, if you didn't buy it from us, you paid too much, right? This is the kind of like claim that these businesses will make. But it turns out that this doesn't actually mean quite what you would think it means, okay? So let's parse out what this means logically. So this is an implication. If something, then something else, okay? So let's write down, so let's say A is you bought it from us, and B is you paid too much. Okay? So using that framework, our logical statement here is if not A, so you didn't buy it from us, so not A implies B. That's what they're saying here. So if you didn't buy it from us, then you paid too much. Okay? So let's look at what the truth table for that looks like. So we're going to set up our truth table. We've got A and B. We're going to need not A, and then that's going to let us do not A implies B. Okay? So A is either true or false. B is either true or false. Not A is the opposite of A. So if A is true, not A is false. Okay? And so now let's look at not A implies B. Okay? So if not A is false and B is true, right? That's how this fits together. This one's false, true. So we're in this situation. The statement is true. If they're both false, the statement is true. If they're both true, the statement is true. And only in the situation where if not A is true and B is false, is the statement false. Okay? So let's parse out what this means. So, in this first situation, this statement is true if you bought it from us and you paid too much. Okay? So now if you think about what the guy or the person yelling this on the TV is saying, is they're saying if you come to us, you're not going to pay too much. But if you come to them and you pay too much, if you bought it from us and you paid too much, this statement is still true. Okay? Similarly, if A is true and B is false, so if you bought it from us, you didn't pay too much, right? Which is what they're implying. That's really what they're actually trying to say, is that if you bought it from us, you got a good deal. You didn't pay too much. Okay? So that's the situation that they want to be true. Similarly, if you didn't buy it from us and you paid too much, the statement is true. Okay, that's fine. That's what they're implying, is that from our competitor, you pay too much. Or the only situation where it is false, where the whole thing is false, is if you didn't buy it from us and you didn't pay too much. Okay? So if you're saying something like this, if you didn't buy it from us, you paid too much, and you want that to mean if you did buy it from us, you didn't pay too much, right? Which would be, if you bought it from us, you didn't pay too much, which would be kind of the opposite of this, right? So if you bought it from us and you paid too much, this statement is still true, okay? So this leads us into the idea of a fallacy, and we'll talk about those in the next section of lectures. But remember, when you hear implications like this, it may not always mean exactly what it sounds like it means, Okay? So in this situation where you bought it from us and you paid too much, that statement is still true. Okay? So we'll talk about fallacies and how kind of it can undermine logical arguments in the next section of lectures.